Okay, I want to work a couple of problems for you today, colligative properties, and I'll start with a simple boiling point elevation. If we have 250 grams of calcium chloride, and we add that to 2 liters of water, what will be our new boiling point? So we can start with our formula that you guys are hopefully familiar with. Delta T equals N M and then a K, and since we're talking about boiling, we're talking about case B, which is a constant that we'll pull from a table. But first we need to find M, which is our molality. So we have all of our information here to do that. So we can start with 250 grams, and we need to convert that to moles. So if I quickly pull up my periodic table, underneath there you can see that calcium is 40.08, chlorine is 35.45, and if we do the calculation, then we find out that our molar mass is 110.98 grams. I'll put that on the bottom so I can cancel my units, and I wind up with about 2.25 moles of calcium chloride. And molality, if you remember, is moles of solute per kilogram of solvent. Now, 2 liters of H2O is going to weigh basically 2 kilograms. So we can go ahead and put, I should have given that a few more sig figs there, but 2 kilograms of water. And so if I do the math, I wind up with a 1.13 mole solution, a little better, mole solution of calcium chloride. Now I can go ahead and start plugging in, and I'll go ahead and pull up my table so we can see our constants there. Okay, so delta T, which we don't know, equals N. Now N is going to be the number of ions that my compound breaks into. In this case, calcium chloride breaks into a calcium 2 plus and also 2 Cl minuses. So I actually get 3 total particles. So put 3 there, put my molality there, and then my Kb. I can go down here, look at water. Notice its Kb is 0.51, and that's going to give me a total of about 1.72 degrees Celsius. Now, this is obviously not the boiling point of water. This is the change in boiling point. So I have to look at my boiling point of water, which you probably already know, but it's here on the table, and I have to add this to that. And so my actual new boiling point is going to be 101.72 degrees Celsius. And that's fairly straightforward. Now we want to take a look at a slightly different way of doing these calculations. And let's say instead of going, let's say we want to go backwards. Let's say that I have 6 liters of water, and I want to get a freezing point of -6 degrees. I should actually put -6 degrees Celsius. So how would I do that? I can also I'll use calcium chloride again. So how much calcium chloride do I need to add in order to do that? So I can start with the same formula. Delta T equals N M, and then of course this time it's freezing, so it's Kf. My delta T I know, because I want to go from 0 to -6, so my delta T would be -6 degrees Celsius. N, calcium chloride, we established that's 3 already. Molality I don't know, Kf. I can look down here on my chart, and it is -1.86. Notice this chart here doesn't actually put a negative sign in front of the Kf like most charts do, but you know pretty much it's freezing point depression. So this is going to be a reduction in freezing point. so minus 1.86. So when I do a little bit of algebra, I solve my molality. I wound up with 1.08 mole CaCl2. And if you recall, that means I have 1.08 moles per kilogram of solvent. And if I want to just work this in a way I can cancel my units. So I have 6 liters. 1 liter is about a kilogram, so we can say that's 6.0 kilograms of water. And that's going to leave me with 6.45 moles of CaCl2. Now from here, it's a pretty easy calculation. We already figured the molar mass of calcium chloride to be 110.98 grams per mole times 6.45 moles to give me a total of 716 grams of calcium chloride. So what that means is if I want to decrease my freezing point of water by 6 degrees Celsius, then I need, I've got 6 liters of water. I need to add 716 grams of calcium chloride in order to do that. Hopefully that is helpful to you. If you have any questions, just let me know.